Hello everyone, my name is Oleg Pankovic. I am Solution Engineer at StarWind. I hope you hear me well and can see the screen with the webinar title. As everyone here knows, HPE announced end of life for StoreVirtual VSA last year. Starting from 1st of January, the product cannot be purchased and the support will end on the last date on 2022. So the current StoreVirtual users should look at replacement to keep the infrastructure stable and reliable. StarWind offers an included migration assistance from HPE VSA for all our software licenses. Today, I would like to give a short introduction to StarWind Virtual SAN, compare it with StoreVirtual VSA, discuss migration steps and concerns. Finally, I will show the migration of two-node vSphere cluster. So then let's start. StarWind can be considered as an old man in the software-defined storage solution market. It was founded in 2008, and since the beginning, our company was specializing in storage virtualization, offering software storage solution as well as hardware appliances. StarWind Hyperconverged Appliance is a turnkey all-flash solution which unified compute, storage, and network stack in one box. It comes with proactive support where we monitor the health of both hardware and software components around the clock. StarWind Storage Appliance is a high-available storage solution consisting of at least two controllers and acts as an iSCSI SAN. StarWind Virtual Tape Library and Virtual Tape Library Appliance emulates physical media tape libraries, supports automatic cloud backup upload, and provides the backup software like Veeam or Veritas with Virtual Tape Repository. StarWind Virtual SAN consists of two subproducts, Virtual SAN for Hyper-V and Virtual SAN for vSphere. The both solutions have pretty same functionality. The difference is that Virtual SAN for Hyper-V runs as a native Windows service and Virtual SAN for vSphere is deployed as virtual storage appliance. We will speak more about VSAN during this webinar. We also have developed some free products which may make the life of system administrator more easier. You may get more information about each product visiting our website. On this webinar, we'll focus more on StarWind Virtual SAN for vSphere. StarWind for Hyper-V has the same working principles, requirements, and network stack. StarWind Virtual SAN mirrors the local storage between servers and provides cluster with high available iSCSI target. It does block-level replication, and all write requests would get acknowledged only once data hits the storage in both nodes. Multipassing is used for iSCSI storage connection, what together with redundancy also increases performance, especially on read operation, because each node may read from two sources simultaneously. As you can see on the diagram, StarWind Virtual SAN minimal configuration can start with two nodes with no external witness required. It is completely switchless and doesn't require any additional equipment to get started. Split brain is avoided by using additional heartbeat connection, which should run on different network card as synchronization. Certainly, the standard approach with witness is also supported. Besides storage mirroring across nodes, StarWind Virtual SAN for vSphere has integrated Linux RAID for systems where is no place for hardware RAID controller. The network backend for a two-node switchless cluster that is responsible for storage synchronization can be represented by two 1 gigabit physical NICs. For flash-based underlying storage, we encourage to use at least 10 GB networks to avoid network bottlenecks. The storage subsystem can be based on either hardware RAID arrays or local built-in Linux RAID, which increases cluster resilience. We recommend RAID 5 for flash-based storage and RAID 10 for spindle drives. Now you see a 3-node cluster. It can be also switchless. If we're talking about network stack, switching configuration is also supported. As well, like in two-node scenario, we don't have any witness instances to provide high availability and redundancy on the cluster storage layer. The three-node configuration has two scenarios of implementation. First scenario is two-way replication. Each cluster data store has two partners of replication. In such way, StarWind VSAN configuration provides 50% of the overall capacity to the cluster. Another benefit of this scenario is the scalability in two basic ways, either adding additional components or additional nodes. Second scenario is implementing the three-way replication. You see the diagram for three-way replication right now. All three nodes have identical data. This scenario achieves the maximum fault tolerance, but has a sacrifice of storage. Only third of row capacity will be available for the cluster. The scenarios with 4 and greater number of nodes in the cluster will be connected through redundant switches. The cluster data stores will be provided to all cluster members, and each cluster data store will have 2 or 3 partners of replication, depending on storage redundancy requirements. The number of physical NICs for such cases will be the same as in three-node case, 4 physical ports per each server. If you're looking only for redundant storage or Ethernet, StarWind VSAN may be deployed on dedicated nodes, which serves for compute cluster running any hypervisor or operation system with iSCSI support, like KVM, Xen, VMware, Hyper-V, and so on. In such scenario, SMB and NFS may be also used as storage access protocol. Right now you see reference architecture with network connection consisting of 2 storage nodes and any number of compute hosts. I assume you are familiar with HPE StoreVirtual VSA. Let's do a simple comparison of features and capabilities in vSphere environment. In Hyper-V, some additional features will be available, like deduplication and automated tiering support. StarWind VSAN allows to build true two-nodes cluster without witness or failover manager. Heartbeat over second network card is used to avoid split brain. The BOS solution operates above iSCSI protocol. StarWind supports also RDMA for vSphere, but only in compute and storage separated scenarios. StarWind supports only 2- and 3-way mirroring. StoreVirtual may also establish 4-way replication and single or dual parity. 4-way replication is rarely used because of usable storage penalty. Parity may save the capacity only starting from 4 nodes. In 3 nodes cluster, single parity provides with 25 more capacity in compared to 2-way mirror, but it also cuts the performance, especially on writes. We support deduplication in Hyper-V cluster. In vSphere environments, deduplication and sync provisioning may be enabled only as non-production experimental feature right now. HPE StoreVirtual VSA supports sync provisioning and no deduplication. StarWind VSAN doesn't have any technical or license limit for maximum storage capacity per node. We have many customers with more than 50 terabytes in 2 nodes cluster. Both solutions relies on local hardware rate redundancy. StarWind for vSphere has also built-in software RAID with MDAD or ZFS for servers without RAID controllers. StoreVirtual supports creation of auto-tier volumes. In StarWind for vSphere, separate tiers should be created for HDD and SSD storage. As mentioned before, we support auto-tiering only in Windows-based vSAN product. Both solutions may use cache, StarWind may use RAM as write-back and Flash as write-through cache. And as for the management, besides native Windows application, we support also HTML5 management with a separate deployed virtual machine. Now, I will highlight the migration steps for in-place upgrade, and next slide we'll speak about the migration concerns. These steps are valid for most environments where there are no third-party storage like NAS or SAN to temporarily move virtual machines during SDS replacement. If you have such storage, the process will be easier. First of all, backup virtual machines before migration. Each migration or upgrade is a risky procedure by its nature. I assume you have some local storage on each ESXi host for boot and HPE StoreVirtual installation. StarWind VSA requires only 16 gigabytes for installation. If you don't have, so no problem, we can completely destroy HPE StoreVirtual on one host and only after that deploy StarWind. So after StarWind VSA is deployed, we shut down HPE VSA on this host, detach the storage, and assign storage to StarWind VSA. Next step is creation of standalone or non-replicated StarWind virtual disk, connection this disk to ESXi cluster, and migration of virtual machines from StoreVirtual to StarWind. After vMotion is done, check virtual machines, detach HPE data store in vCenter, detach storage from second HPE VSA, and configure replication in StarWind. And the last step is to remove both StoreVirtual VSA. Despite the migration process may look straightforward, there are some concerns which should be taken into account. It relates not only to StoreVirtual to StarWind migration, but almost any other storage migrations. Most HPE StoreVirtual infrastructures run or on 4 years old hardware with HDD drives or with hybrid storage. HDD are often in RAID 5. During in-place migration, for some period of time the replication will be broken, and only one server, if we are talking certainly about two-way mirror or single parity, will store actual data. The storage subsystem is under pressure during migration, and there are small risks that a node or a disk will fail. RAID 5 protects one disk failure, but as all drives are probably from one batch, the second one may fail and the whole array is lost. That's why backup is a must. The second one is migrating terabytes of data stored on spindle drives over 1 GB channel with, let's say, 100 megabytes per second bandwidth will take hours or days. The theoretical value is 3-4 hours per terabyte, which doesn't include potential storage load by running virtual machines. With 10 GB networks, the spindle volume throughput may be also a bottleneck. And don't forget that we need to copy the data twice, one time from HPE VSA to standalone StarWind device, and then StarWind device will replicate the data to partner host. Suddenly, in all-flash systems with 10 GB networks, the things are better because of faster storage. The third concern is related more to deployment without involving the vendor of target software-defined storage solution. The new solution may be misconfigured, which may lead to immediate issues or troubles in future. Sometimes the system or storage requirements storage solution may vary. An example, HPE StoreVirtual require only one channel for storage traffic and one for management. StarWind requires two for storage, dedicated for iSCSI and synchronization, and one of management. Certainly if we will use Heartbeat and no witness. With witness configuration, only one network channel might be also used with StarWind. Another example, we highly recommend using RAID 10 with spindle drives to get more performance on random writes. HPE StoreVirtual recommends all RAID arrays, RAID 5, RAID 6, or RAID 10. And the last one, that actually storage vMotion is required to move storage, but there is also a workaround. with enhanced vMotion feature included in vSphere Essential Plus Kit license. So the minimal vSphere license for in-place upgrade without any downtime as vSphere Essential Plus Kit. StarWind offers migration assistance, and during this assistance, our engineers will evaluate the existing infrastructure, prepare and execute migration plan. Good, now let's move on and watch the migration in action. Here we have the cluster, which consists of two ESXi hosts. On each ESXi host, we have deployed HPE VSA, and the local storage is connected as row device mapping. We have two RAID volumes, one of approximately 4.5 terabytes based on HDD, and the second one is 1.3 terabytes based on SSD. I have already deployed but not configured StarWind VSA on both hosts. And certainly we have some test virtual machines, 1, 2, 3, 4, which are allocated on HPE data stores. We will check hard disk. We see that the VMDK is stored on HPE 02. If we will check the data stores, we have only two local with ESXi boot partition and HPE Store Virtual VSA installation, and two shared storage, HP1 and HP2. So let's go now to CMS console. Okay, it is still loading. We need to wait some time. CMS is searching for active management groups. Okay, I see the group is found. Let's log in. StarWind. Okay, good. See here vSphere cluster and two volumes. Good. Let's shut down the second system. Let's check if the storage can be used. First one, the second one looks good. Okay, the manager is stopped. We can turn off this the HPE VSA on second host. Okay, we need to detach the storage. And attach the storage to StarWind VSA running on this host. We're using Crow device mapping, but actually VMDK are also supported, and even PCI pass-through over the entire RAID controller, or if we're talking about NVMe drives, are also supported. Good. Now we need to prepare the storage. Oops. Okay, let's log in. Now we will see these both devices here. Let's create partition table. So actually for production, we advise to overwrite existing data with zeros. Certainly it will make the migration time much longer, but it can have effect on performance after the migration. We need to create partition where the StarWind images will be stored. Mounting HDD. Partition is created. We can mount it. And the second read volume. Okay, still formatting. Okay, now we can mount it. Good, we have prepared storage on one StarWind VSA. Now we need to open StarWind Management Console and create standalone virtual disk. StarWind VST01. For ASXI environments, we use only 512 bytes sector size, and certainly no cache for SSD drive. Good. Standalone SSD device is created. Now we can connect it to both ASXI host, and after that start the migration. I use here the IP address which is dedicated for iSCSI. And after configuring the IP, we need to rescan storage. The same should be done with second ASXI host. Rescan storage. Let's check storage devices. Oh, we see StarWind iSCSI disk. 250 GB right now. Let's create data store. Okay, let's check this data store. If both hosts can access it, yes. Good. Now we can start migration. So if you don't have vMotion, you need to use, if you don't have storage vMotion, you need to use only change both compute resource and storage. If your license allows storage vMotion, then you can use only change storage. Second virtual machine. The set one. And the last one with Windows Server. Okay, now we need to wait a couple of minutes for storage migration. If we will go to StarWind Management Console, then we will see the IOPS count for storage, the increased IOPS count, the increased bandwidth. Okay, on the 2 virtual machines left. And I also would like to show you our landing page where you can request our assistance for migration from HPE StoreVirtual VSA to StarWind VSAN. So this offer relates not only to Whisper environment, but we also support it in Hyper environment. Good. Let's check. We need a couple of minutes more. Okay, only Windows servers left. How much storage does it have? I think we have 50 GB. Yeah, if we check the StarWind VSA settings, we'll see the three networks are touched. One network, it is a management connection. It can be shared with any other traffic, and also additional heartbeat could use this network. And two storage networks. One storage network is used for data synchronization between hosts, and the second one is used for iSCSI access. Here, the both ASXI hosts have direct attached network links for storage 1 and storage 2 traffic. Okay, Windows Server virtual machine is migrated. Let's check. Yeah, looks good. Now I would like to check if we have some files on HP storage. No. No. So then we can detach the both HP data stores. So that's first of all our mount. Okay. It. These data stores can be removed. Okay, unmounted. Now we may delete it. Good. Now let's shut down the HP Store Virtual. Edit settings. Detach local storage. Connect local storage to StarWind VSA on the second node. Go to StarWind VSA management. SSD. partition. Now need to wait. This one we can mount here. And I think this one is ready for mounting. Yeah. Okay. Let's go back to StarWind Management Console. I will create a second StarWind device, the second host, because Whisper high availability requires at least 2 shared data stores for proper work. One. So I will replicate this newly created disk with a second node. So here you can choose what follower strategy to use, either heartbeat with no external devices or witnesses, or node majority. We recommend to use heartbeat if the both server, for example, are in the same rack, the same data room. If we are talking about the storage clusters, then depending on the amount of redundant links between each location, you should choose either heartbeat or node majority. But right now we will choose heartbeat. Create partner device. Now we need to choose the right location for this network device, and the last but not the least, select proper network interfaces for synchronization and heartbeats. So looks good. Now we can add replica to our existing data store. Okay. We have here 2 tiers, one on SSD already with virtual machines, which we have migrated from StoreVirtual VSA, and second tier based on HDDs. Let's extend the size. And right now we can rescan storage. Those hosts. And we will see the new StarWind device without data store. Let's create the second data store. StarWind HTT01. Like text data stores. Need to rescan the storage. This is ASXi host. Yeah. So as now we have two shared data stores, this warning will disappear in some period of time. And here we need to wait 30 minutes more until the virtual disk with current virtual machines will be synchronized completely from the second to the first node. As you see, the virtual machines are continue running without any interruptions. So this one is also, I think, yeah, looks good. So actually, after 12 minutes, the cluster will be protected again with StarWind VSAN as a software-defined storage provider. If you need any assistance with migration and if you are interested in our products, please do not hesitate to contact us using email or phone, or you can just fill this form and our engineer will contact you to discuss the migration procedure. Right now, I would like to thank you for your attention. I wish you to have a nice day and goodbye.